So today we are going to start with alkenes. We know that they are hydrocarbons. Hydrocarbons are the compounds containing hydrogen and carbon. Also hydrocarbons are saturated and unsaturated. Saturated we have already read regarding alkenes. So today we are going with alkenes, whose general formula is CnH2n. Now let us consider if n equals to 1. When n equals to 1, then what we get? We get C1H2. There is like this. That means what? There is no such compounds having, because the valencies of carbon is 4, which is not here satisfied. So now let us take here n equals to 2. Then what happens? We get C2H4. Then it becomes like this. H. So already H4 is satisfied. Now carbon here it is 2 has been shared, so it makes a double bond with another carbon atom, that is here. So all the 4 valences are here satisfied with a double bond. Since in this it is a double bond, and see here we can see that they are not saturated with the hydrogen. Hence such type of compounds are called hydrocarbons, which are unsaturated hydrocarbons, as there is a double bond here. Here the general formula of alkene is CnH2n. So ethene means n equals to 2, we have C2H4. Condensed formula is CH2 double bond CH2. Structural formula we can write in this way. C2H4. Tribal name is ethylene and the IPAC name is ethene. We must know before this exam. So now we are going to study about the isomers in alkenes. Alkenes having 4 carbon atoms or more than 4 carbon atoms can form isomers. The very first 4 atoms of alkene is butene, whose formula is C4H8, as the general formula is CnH2n. Now in alkene there is 2 types of isomers are formed. Number 1 is position isomers, that is position isomers, and number 2 is chain isomers. In position isomers it depends on the position of the double bond with the carbon, and in chain isomers it depends on the position with respect to the parent chain in the structure. So let us go with the position isomers of butene. Here we have, as I already said you, that position isomers, it depends on the double bond. See here the double bond is here, so we are writing here but 1ene. Now in the second one here, double bond is here, so another position isomers is but number 2, that is 2A. Next we are going with the chain isomers, that is we are having in this way, that is 3 carbon atoms and this is the parent chain. We are going to write it down here. So this is what we can write here, 2-methyl propene. One of the foremost question which is important, that is laboratory preparation of ethene, that is C2H4. Now ethene in the laboratory is prepared by the process of dehydration of ethyl alcohol, where we use excess of concentrate sulfuric acid at 170 degrees Celsius. But in questions, in the board questions, they may give you different types of questions. They ask you write down the laboratory preparation or give the equation, laboratory equation. So it may be, there may be 2 types of equations, that don't be confused. One they ask you complete equation, one they ask you direct equation. So be aware of the questions properly. I will show you the complete equations how to write it here. We try to understand the mechanism. See here we have ethyl alcohol, that is ethanol, when it is reacted with H2SO4. H2SO4 means it is H plus HSO4 minus, and from this part gets replaced with this. So finally what we get, CH3CH2, CH3CH2, HSO4 plus HOH, that means H2O. This is ethyl hydrogen sulfate. Next We are taking this part here and putting excess of H2SO4 with 170 degrees Celsius. We are getting what? We are getting C2H4. This is C2H4 plus H2SO4. Now suppose if we add, this is the complete equation, and suppose if we add this, see here, this gets cancelled off with this gets cancelled off with this. So finally what we have is CH3 CH2OH. In the left hand side, this gets cancelled off with this, and this gets cancelled off with this. So finally we have here excess of H2SO4 170 degrees Celsius, and on the right hand side we have C2H4 plus H2O. In laboratory it is collected. How it is collected? The gas is collected by the downward displacement of water. Why? Because the reason it is given here, it is insoluble in water, that is, it is sparingly soluble in water, and it is inflammable gas. Next question, write down the reactants taken. So the reactant taken is ethyl alcohol and concentrated H2SO4. We have to not forget their ratios. Their ratios should be 1:2 part. Next question is, the gas is passed through sodium hydroxide solution. Why? Because to remove the carbon dioxide and sulfur dioxide impurities which is formed by the acid. So aluminum sulfate is added in water in the laboratory preparation. Why? Because in order to avoid frothing occurs to avoid that one. Write another reactant from which ethene can be prepared. In the laboratory method we used ethanol, that is ethyl alcohol and sulfuric acid, but here we are using alumina at 350 degrees Celsius and we are getting ethene. Here now ethene can also be prepared by dehydrohalogenation. See here, dehydrohalogenation means halogen can be taken as chlorine, bromine or iodine. So hydrohalogens means taking out of hydrogen as well as halogen from the compound. Now we are using alcoholic hot concentrated, this one potassium hydroxide. What happens is here, from here it becomes C2H4, then one H is left over here, H and Cl is left over here, which here potassium reacts with Cl and H goes with OH. That means what? We are getting C2H4 plus KCl plus H2O. So this is the main mechanism. Now we are going to study regarding the how the reaction takes place. Since ethene is unsaturated hydrocarbon having double bond, so it goes with addition reaction. There is a lot of addition of reaction, but in our syllabus we have addition of hydrogen, then addition of water and addition of halogen groups as well. Number one addition reaction, that is hydrogenation, addition of hydrogen. So these are passed through the catalyst nickel at 200 degrees Celsius to form ethane. What happens is this, to this unsaturated hydrocarbon, two atoms of hydrogen gets here added up to form this. So this hydrogenation can also be done with the other catalysts like platinum, and we can use platinum as well as palladium at room temperature to get dehydrogenation of ethene. Next addition reaction, that is halogenation, that is addition of halogen. We must reaction, halogen means chlorine, fluorine, bromine. So reaction with fluorine is very explosive, hence compound form is not stable. Also reaction with iodine is very slow, so which is unstable because it often regenerates, again it regenerates ethene by liberating iodine. So what we have is halogenation with respect to the chlorine. When we get C2H4 plus Cl2 gives CH2 Cl2. This is what we say is 1,2-dichloroethane. 1,2-dichloroethane. More addition of water, that is hydration. So when it is addition of water when it occurs in presence of H2SO4 acid. So what we get here is H plus ions we are getting, as well as ethyl alcohol is formed. Ethyl alcohol is formed. Next, many uses of ethene is as well as manufacture of synthetic chemicals, ripening of fruits, and making polythene as well.